Don't know if that really, there it is. Welcome back, my friends, to the show that never ends. This is the vBrownbag US podcast. Today is Wednesday the something or other. It's been a long while since I've tried to pay attention. Wednesday, January the 14th, around 7:30 Central, 8:30 Eastern. Tonight we are talking PuppetInABox with Mr. Rob Nelson, rNelson0 on Twitter. It is a continuation of our vBrownbag DevOps series. The same page you used to register for this has all of the recordings, homework, labs, and a lot of the labs are downloadable. You can work with them on your own laptop and so on, that give you a soup to nuts, build yourself a lab, get everything operational, learn the DevOps concepts, and so forth. If you want to hop in the conversation tonight, our Twitter hashtag is hashtag vBrownbag. Our Twitter handles are there. I'm not going to try to read them all out to you. We run a bunch of other shows, APAC, EMEA, Latin America, US, all at various times. I'm not even going to try to, again, it's on the slide, it's on the recording. Y'all can read pretty much as well as I can, I hope. All right. Again, our guest tonight is Mr. Rob Nelson. And Rob, if you are ready.
I am.
Great. There you go. Maybe.
Right. Is that visible now?
It hasn't shown up here yet. There it is. Showed up behind the other window. So yes, I do see you.
All right. So hello, everybody. My name is Rob Nelson. I am a security and systems administrator at AT&T. You can follow me on Twitter at rNelson0 or on my blog, rNelson0.com. Tonight, I'm going to demo a new project I released just last week called PuppetInABox. PuppetInABox gives you all the Puppet components you need to stand up a small network using some common patterns and best practices from the Puppet community. You don't need to know much about Puppet to use it, but it does help. Jeremy Adams covered Puppet in another vBrownbag, so please go take a moment after this if you're not familiar with Puppet to review his in-depth primer on Puppet. But I'm really going to be focusing on this project, PuppetInABox. And you can find that on the professionalvmware.com under the DevOps series. So I'm going to address first why I use Puppet. Then I'm going to talk a little bit about the 12 days of commitments and how that led to PuppetInABox. I'll explain how it works, and then I'm going to finish off with a live demo. There should be plenty of time at the end for Q&A, but feel free to ask a question at any time in the chat window or with the vBrownbag hashtag on Twitter. A majority of the time is going to be spent on the demo, so we'll keep our fingers crossed that all goes well there. I am going to be moving pretty fast because it will take about an hour to get through everything. And with that live demo, I'm a little nervous to make sure we hit everything. So let's take a look at configuration management and version control first. As many of you are probably aware from this DevOps track, the use of configuration management, or CM, it's a vital component to high-performing IT groups. And version control is also extremely important. Together, they help us ensure the consistency of our system states, help audit and diff changes, and allow you to return to previous states as you need to. You can do this for everything. The application itself, the application's configuration, OS, network, DNS settings, etc. Usually when people think of version control and config management, they think of just the software, but the config files are just as important. Having those config files in version control is another leading indicator for high-performing IT groups. And of course, that's where we all want to be. So for these two tools, I use Puppet for config management and Git for version control. Now, there's a lot of CM tools out there. Here's a few: Chef, Puppet Labs, SaltStack, and Ansible. But why do I use Puppet? Well, it's easy for me. It's because it's popular. Puppet's popularity is actually a very strong reason to choose Puppet. It's one of the fastest growing tech skills, which means you're going to be able to hire other people who already know Puppet. There's over 3,000 publicly available modules on the Forge, which is the module repository from Puppet Labs. So if you need to do something, somebody else has already probably done it, or has at least started on it, something for you to build on. There's also a great community on Twitter and IRC, so if you need help with figuring out how to do something with Puppet, it's just a few keystrokes away. There's also some other reasons than popularity, of course. We can do bare metal provisioning with Puppet Razor. It can manage your networking gear if it's on the compatibility list. And VMware, which a lot of us know and love from our virtualization side, has invested heavily in Puppet. And if you need more reasons, just go out and Google for why Puppet. And I've got a post on my blog called Why Puppet. Now, it's important to remember there's more CM tools than any one person can ever evaluate. Choosing any one of these will free up enough time so that if you ever need to change tools later, you'll have that time. So I'm going to talk about Puppet tonight, but I really don't care what tool you use as long as you're using some sort of CM tool. So get started sooner. And here's some links about CM and Puppet. These will be on the slide share that I'll post tomorrow when the video goes live, so you'll be able to see them there. So now that we know why I'm using Puppet, why am I using Git? Again, it's popular. If you're not familiar with Git, you can easily find tons of documentation on how to get started, common workflows, common problems people run into, and the fixes for them, how to integrate it with all your existing tools. It's not tied to any vendor or specific IDE or platform, but it can also be used for social coding. With sites like GitHub or Bitbucket, you can easily share your projects like I'm doing with PuppetInABox with the whole world with very little friction. So I'd recommend, if you're not familiar with Git, taking some time to learn it. It's a skill you're absolutely going to need in the next few years, no matter what your role in IT is. So to help people with Git and social coding, vBrownbag's own Matt Brender did a Git presentation earlier in the DevOps track, and then he followed it up with the 12 Days of Commit-Miss project this past holiday season. The goal was to encourage learning and familiarity with Git by committing to using it for 12 days in a row. Now, don't worry that the holiday season is over. You can still go out and check out Matt's GitHub repo at any time and have your own 12 days of crappy winter weather or whatever works for you. I took part in Commit-Miss to try and learn how to use Git myself. I was familiar with it, but making it part of my daily practice. Practice makes perfect. And I can tell you that after a few days, you're looking for something else to use Git with because you run out pretty quickly. And this is where PuppetInABox comes in. My home network had needed some upgrades, but I've been putting it off because lovingly handcrafting new VMs really stinks. It takes a lot of time, it's fraught with danger, and no one wants to interrupt your home network. So now that I'm using Puppet in my home network, if you go out to my blog, you'll find I've done a lot of articles on Puppet. That's great because that's where my vSphere lab is. But I've got quite a few VMs that predated my Puppet setup. So I decided I could kill two birds with one stone, partake in Commit-Miss, and refresh my home network at the same time. So as I mentioned earlier, you need to do config management and version control of all the things, not just the software. So I spent most of that 12 days of Commit-Miss and some time afterward documenting my home network services and crafting Puppet manifests for each service. The initial goal was to make it so I could simply shut down my old VMs, spin up some new VMs, and keep the spice, that is the streaming media, flowing. Because maintaining SLAs at home is just as important at work, if not more, especially if you want to have that lab budget. So in spite of my planning, wasn't entirely successful in meeting the SLA. A few hours without DNS one day and no DHCP for an hour or two another day, but I did make it through. And I'm really confident now that I could go out and burn down any of those VMs and stand a replacement one up in less than 30 minutes. And most of that would probably be the time it takes to deploy from template. So after I was done working on a home network, I had a rare thought. This was kind of difficult for me, and I bet other people probably have the same problem. So this gets us to PuppetInABox. If your home network needs a refresh, you need to stand up a proof of concept lab at work with Puppet, or you just want to play with Puppet, PuppetInABox aims to make this quick and easy. And it does exactly what it says on the tin. The box contains Puppet and some config to provision some common services. All that's missing is a gateway to the rest of the world. You provide that, the rest is all there. Puppet, DNS, and DHCP services are mandatory. You're going to want those on any network anyway. The build and yum repo nodes at the bottom are optional. Now, a build server for me, that's where you go to create software and do your coding. It's not necessary for everybody, But for me, it works really well. I work on a few different machines, and it's comforting for me to know that I can just SSH into the build server. All my software, all my Git repos are there. But you don't need to use that if you don't want to. Yum repo is where you'd store any software that you've packaged up and serve it to your clients, which are normally your Puppet managed nodes. Now, PuppetInABox should work with pretty much any enterprise Linux-based distro. I've tested it with CentOS 6.5 and 6.6 myself. All you need to do is have a Linux template that has Puppet on it. If you don't have one, you can go out and build one with Kickstart. I've got an example on my blog. I'm sure plenty of other people have examples, and a lot of us probably have a Linux template already. The provided network that PuppetInABox comes with is 10.0.0.0/8. It's got DNS entries for all the hosts that are provided with it, and it's got DHCP scope and reservations. There's also one local user called padmin. That user ends up being a member of Wheel, which means they get sudo access, so you don't have to use root. That's best practice to log in as a non-privileged user and only gain privileges when you need it. So again, we're trying to adhere to best practices. Now, this is just a starting point. Everything can be custom. You're not locked into what I'm providing here in the project. In fact, it's mostly there just to provide samples and correct syntax. You're also not restricted to managing networks within that node, within the network that it defines, so long as those other nodes outside the network and the Puppet server can communicate with each other. Just open a firewall rule or make sure it routes, and everything should be good. And in fact, to show you how easy it is to customize the setup, I'm going to be using 10.0.1.0/8 because guess what? I developed all this on my home network, which is 10.0.0.0/8, and I don't want to interrupt that. So that's pretty much my intro to PuppetInABox. We're going to do a demo, going to show how it works, and then show it in action. As I go through it, I'll be talking about the roles and profiles pattern, which is another Puppet best practice. If you want to follow along with that, Google for that phrase, designing Puppet roles and profiles. Take a look at the first link on Craig Dunn's blog. And I'm also going to talk about R10K, which is a piece of software that is supported by Puppet Labs. You can just go to github.com/Adrian Thebo, that's ADRIENTHEBO/R10K, and you can take a look at the documentation there as we go. Cody, are there any questions before I get into the demo?
None as yet, I don't think. Oh, hold on. One just popped up. Why did you use PuppetInABox rather than, say, Autolab?
So for me, I like the PuppetInABox because I can keep everything in config management. The genesis of this is my home network. So as I make changes in my home network, it's not part of the Autolab, it's part of Puppet. So if I need to, I can burn down VM, bring it back up. I can make multiple of the same type of VM, but it's all controlled through config management. Autolab, I think, does some great things to stand devices up, but it doesn't have, from what I've seen, I haven't used the latest versions of it, but from what I've seen, it doesn't have that close tie to config management, which to me is important. Even though it's my home lab, I really like having it. I do it at work. Why not do it at home?
All right, that was it for the questions.
Okay. Well, I am going to pull up my documentation here so I can go through this demo, and it is going to take pretty much the rest of the time. But if you have any questions, raise your hand, and I will get to them as soon as Cody lets me know there's a question. So the PuppetInABox project exists on GitHub. You can see up here it's just github.com/PuppetInABox. And when we view the organization page, you're presented with a list of 8 repositories. Now, we all know no one reads directions, so we're going to skip the documentation repo, and we'll come back to that later. So the first item is the control repo. In Puppet parlance, the control repo contains just a small bit of Puppet code. It contains the site manifest, which has just a few lines. It's going to do some lookups in Hera for a class's value. It's going to do some magic with some more magic with Hera and SSH authorized keys to propagate that, and that's it. That's our site manifest. So that's our main code or that's the equivalent of like a main subroutine. And aside from that, the real reason it's called control repo is because of this magic file called Puppet file. This controls all the modules, which are basically the defining code that site manifest references that are loaded on a Puppet master. So here we've got a Forge URL, we've got names of Puppet modules and versions. You don't have to put a version, but I like to pin it so that way when somebody does something like go from a 1.x to a 2.x, I actually have to subscribe to it. But after you define all these public Forge modules, then you get down to R modules. And I'll go through these in a bit, but these are R modules on GitHub. They're not on the Forge. So you just need to give them a name and the URI for Git. And if you have any sort of internal repository, Gitolite, Bitbucket, Stash, anything like that, this should work with all of those, as long as the Puppet master can communicate with this destination. That's the only requirement. So we've got these, I mentioned the role and profile pattern, so those are these two modules here. We have a custom facts. A fact is what it says. It's a fact about a node. So the IP address, the host name, the fully qualified domain name, SSH keys, those are all facts about a node. We've got a module here that defines just one additional fact, but you can always add to that on your own. Lab config is where we store some files. Puppet's great for data. You really don't want to store files because then you'd have to do some sort of encoding or XML, and that's just, nobody wants to do that. And last but not least, we have a little module that defines some firewall rules. And this basically just replicates the base IP tables from CentOS 6. You certainly can customize that, but that's probably the least of our concerns. So let's take a quick look at how the role and profile pattern works. We have our role repository, and in it we have a manifest folder, and we'll take a look at the Puppet class. So this is for our Puppet master. And the way it works is a single role includes multiple profiles. So you're layering this together. We've got a base profile, and all roles get that. We've got the Puppet master profile, the puppetdb profile, and the hero profile. And if we go over to the profile repository and we take a look in the manifest here, we have a base module, and this is just what it says. It's something that you want every device to have. So we've got our firewall rules here, some defaults for SSH server and SSH client settings. You know, this is where you would go if you wanted to disable permit root login. I've left it enabled, but that's something you can easily change on your own. Your NTP, if we have that yum repo, then we would load it here. And a few other things, the sudo setup, the local users, things like that. And then if we go back, we'll see the Puppet master. It adds the EPEL, that's the extras repository for CentOS. That's where we'll need some modules out of that. And we have a class here that allows us to load the Puppet master services without having to go and define everything, because that's just a lot of stuff. You've got a database that backs it. You've got the Puppet master service itself, the package. So as I mentioned, that Forge module, you can download modules that have all sorts of things that you need already. And rather than having to define that myself, I can just go out there and use it, and I just pass it the things that I want to change. I think store configs defaults to false, and I don't know what environments defaults to, but not what I want. So those are the only things I needed to provide. Now we're also adding the package R10K, and I'll show that in a minute, and a firewall rule. The agents check in on TCP port 8140. So if you were managing devices outside the network, that's all you need is to allow port 8140 TCP into the Puppet device. So R10K, if you currently use Puppet but you haven't used R10K yet, you're really missing out. R10K takes our control repo over here, and it's going to deploy the contents of each branch into our Puppet environment. So if we take a look, we only have one now, but it'll take everything in here and deploy it into the production branch. If you're modifying your code, and you want to test something out, you just create a new branch, push it to GitHub, and run R10K, and it will create a new environment with that branch name. Seems like a bit of work. It's not really that much work. It's just a little bit tedious, and there are some ways you can reduce the friction as well. So we'll get to see what this looks like in a few minutes. And there's one other big technology that matters. That's called Hira. So Hira allows you to separate your data from your code. Hira is a key value data lookup service. It uses a hierarchy to determine where to find the value it needs. Actually, let me go back to the control repo. We have a hira.yaml, which is the config file for Hira. It defines a backend that's in YAML, so it's text files that look similar to this. We have a hierarchy, and you put your most specific values up at the top and your least specific and generic values down at the bottom. So if it finds a hit up here, that's preferable to the one at the bottom. And we have a data directory, so this is where the Hira data files will be found. So where it says like puppet role / and a puppet role, that's actually going to be etc puppet Hira data / puppet role and then the file name. And there are other backends you can choose as outside of YAML. You can do JSON for other text. You can also use MySQL to interface directly to your database, or Redis, and there's a few others. There's a YAML for encrypted stuff when you need to have secrets in there that you can't trust other people. So we'll take a look at the Hira data, and we'll look at a DNS role because that's very easy to understand. If we go over here to the DNS, we see the classes value. If you remember from the site manifest, we did some magical lookup of Hira, and it just returns us one value, one role. Each node should have a single role. If you find yourself needing to put 2 roles on a device, you really just need to make a new role that has the superset of profiles that you need. Now we also have some other values that are used by that role DNS and the profiles it contains. We've got configs for our bind server. Here's the etc named.conf file with a listen address, allow query, some zones. And we've also got the server files, which are the zone files. And what's happening here is for the example.com zone, which is defined up here with this file name, we're going to look at another module called lab config for the file contents. And same thing here for our reverse lookup. And again, this is all sample data that you're seeing here, but it's perfectly usable as is, and it's a great base for customization because the syntax that you see actually works. And there's one other service that PuppetInABox provides called puppetdb. Now, that database collects reports on every Puppet agent run, and it also gets exported resources from the different nodes that check in, such as SSH identity keys. Now, all we use it for in PuppetInABox is the SSH identity keys. Every Puppet node exports it, PuppetDB grabs it, and then when a node checks in, it gets all the exported keys that are already in PuppetDB. Those SSH identity keys are what you see when you SSH between 2 nodes, and it says this is the key from the node, are you sure you want to connect? So by having this in here, whenever you SSH between your managed nodes, you won't get any of those pop-ups. If you get a pop-up asking you if you want to connect to a device, here's the identity key, you've probably got some sort of security issue. Now that's all that we do with PuppetDB today, but it's there so you can start building reports or using other exported resources when you're ready. All the data is still being collected even though you're not using it. All right, so that's a whole bunch of backing technology and code and data, and it's just lying around. Next thing is to try and use it. So it's about time to look at those instructions. So we're going to pull this up here. And we've got a preparation section that we want to take a look at, and then we'll get into the Bootstrap. So I mentioned earlier you need a gateway device and a Linux template. Obviously, you have to have those ready. Next, you're going to need to fork or duplicate some repositories. You can't write to the ones from PuppetInABox, so if you want to do any customization, you're going to need to fork it. The mandatory devices or repos to fork are the control repo, the Hira, and the lab config repos. Role and profile, if you're not going to actually customize roles and profiles, you don't need to. And then custom facts and Linux firewall, most people probably will not need to fork those. Now I want to note one thing here. all of these repos are public, otherwise you couldn't see them. When you fork a public repo on GitHub, it stays public. If you are going to add any sort of private data, whether it's home or work, say some certificates or IP addresses, you probably don't want to share those with the world.
Your git ignore file is critical.
Yes, your git ignore file is critical. You've probably also heard some horror stories about AWS keys in public repos. You do not want to be one of those people that wakes up to a $5,000 bill from AWS because somebody started running Bitcoin miners. So if you don't want to be one of those stories, it's a good idea to use private repos.
Okay, so we did have a question come up real quick about all of this is open source Puppet. There's no Puppet Enterprise.
Correct. You theoretically could use this with Puppet Enterprise, but given that that only goes up to 10 nodes, I felt that that probably wasn't a good idea to base this on. So if there's interest in it, I can probably look into doing something with that. And I certainly, this is all public, so if somebody wants to look into that and wants to submit a PR, I will gladly accept it and review it. Were there any other questions?
That was it.
Okay. So the private repos, it's like $6 a month for I think up to 10 repos, $72 a year. If you've got anything private, that's much cheaper than a $5K bill. So I'd recommend setting that up. Now the downside of that is, as I said, when you fork your repo, it's going to be public as well. There's no one-click button to make it private anymore. GitHub took that away a couple years ago. I'll put a link up here. There's directions to duplicate it. I'm obviously not going to go through that now, but I want to make sure everybody's aware so that you aren't part of a horror story. So let's take a look at my repositories. I've gone and forked the control repo, the lab config, and Hera. And there's a few changes that will show as we go through the Bootstrap process, but I just want to show the small number of changes required to re-IP the network. In the control repo, we have a temporary host that we have to add during the boot process. That's in this host add.pp. All I needed to do was change this IP to the correct network. And in the lab config, we have DNS files. The reverse lookup, there's no actual changes to it, but I changed the name to match the 10.0.1. And in the forward lookup, just changed the third octet for all of the entries. And lastly, over in Hera, if we take a look at Puppet role, we've got dhcp. And I had to change the third octet here for all the dhcp information for the subnet itself and all the values underneath it. And for DNS, same thing. Change that third octet, change the reverse lookup file name here, and here, and here and here. That's all you need to do to change the network. So once you've got these repos forked and or converted to private, you can really get started in the Bootstrap section here. First step is, after you've got your gateway in place, is to deploy a VM from your template. You call it Puppet, and the suggested IP, if you're using that network, the predefined network is 10.0.0.5. Mine is at 10.0.1.5. And if you're playing around to learn, that's a great time to take a snapshot before you begin. As long as you've got Puppet on it, you should be good. If you are going to be going back through, I'd wait until you get at least your second node working, and then you can ditch the snapshot. As we all should know by now, snapshots are not backups, so it's not long term, but you can keep it there through the first few nodes turn up. So here is my Puppet node. Now, the first thing that we need to do, I'm going to try and run these side by side, and hopefully it's legible. If I move too fast just for humans in general or for the screen share, just let me know. So the first step is generate some SSH keys for root. You have to add them to your repo, otherwise you won't be able to do a git clone or git commits. I've already done that because I don't want to show everybody what my SSH keys are. And let's see, oh, one other consideration, DNS. Now, there's no DNS in the server already. And my templates customization spec provides the IP address for the PuppetInABox DNS server. So I've kind of cheated a little and I've swapped it around. This is my gateway as DNS, but really eventually this one will be first. We'll swap it back when we're done. If you're deploying from a template, I'd say it's probably easier to make this to kind of cheat on the Puppet master, but on your other devices, you just want to make sure that the actual DNS server, once it's provisioned, is their primary. So next, we're going to clone the repo just like it shows here. And we're going to cd into the directory. We're going to add a module that's used for the Bootstrap process. This module here called ZAC R10K actually will install R10K and do some configuration. So let's get that in place. And that might take a minute or two. And while it's doing that, I've already made these changes to the control repo, and I'll show them. But basically what you have to do is any of the repos that you've forked, you want to replace that PuppetInABox name with your name and your repo name. Most of the time, if you just hit the fork button, it'll be this, but my control repo, which gets forked down here in this other file, has a 1 on the end because I already have a control repo. So if we take a look at our Puppet file, all right. So I didn't follow my own directions here. I note in here a few times that you are supposed to use your forks, not the main ones. So always make sure that you're cloning your repo, not the organization repo. Let's try this again. Okay. There we go. So you can see I've changed all the modules down here to match mine. The Linux FW one, I also had one called Linux FW, so that gets a 1. And then in the R10K installation script, change that and that as well. And of course, you have to commit and push them up there, which is later in the instructions, but I don't need to do that because I kind of cheated. So the next thing we need to do is copy these default Puppet and Hero config files from the control repo into the correct locations. We skip that commit and push step, and now we're going to actually perform the R10K installation via Puppet. And the reason we do that is because you could certainly go ahead and install R10K yourself, but Puppet DSL is nice cross-platform, so whether you're using Ubuntu, Debian, Red Hat, CentOS, something else, that should go ahead and work for you. This is going to take just a minute or two. Do we have any questions while we're waiting on that, Cody?
So the only question of note is how to actually pronounce Hira or Hira, Hira.
I have not been to a Puppet Conf, but I have heard that it gets pretty contentious.
And so I'm fairly certain that there are camps on either side, even within Puppet itself. So actually, I've got the Mac up. Let me just go ahead and pipe that into say, right?
I'm pretty sure that if you go out to the Puppet Lab site, somewhere in their FAQ, it says, how do you pronounce it? And there's a funny answer.
H-I-E-R-A.
Oh, something else while we're waiting here. Oh, that finished. I'll get it in just a second. So now that R10K is installed, I told you R10K does a little bit of magic, goes out and pushes everything from the Puppet repo. You run R10K deploy environment. The -P stands for Puppet file, and I'm going to add the V flag for verbose so we can see what it's doing. And this is going to go out, pull down the information from the branches. I'll make this full screen so it doesn't scroll. You can see I have a feature branch. I'm going to get rid of the feature branch for now. We'll add that in later because that will just take way too long. But you can see it found the feature branch that exists and started to create a branch for it. We really don't care about that right now, so we're just going to have our Hero data. and our production branch off the control repo.
All right, we did have another question, actually two questions come up. One, it was cross-platform support, so that means Linux only. And then the second question was, and I think you just finished explaining it, is what is R10K doing at this moment? Okay.
So the first thing, cross-platform. The Puppet DSL itself is cross-platform. You can use it on Linux, you can use it on Windows. I think you can use it on Mac, but I don't know that that's fully supported by Puppet Labs. However, the Puppet Master can only run on Linux. So that's a limitation for the master. But all the managed nodes can be any OS you want. You know, clearly there's some support with different versions, but the main Linux, Windows, and Mac I think are covered. There's a lot of work being done with Puppet and Windows these days. If you think that you can't script stuff with Windows, that's probably correct, but you can certainly manage it with Puppet. A lot of it is Puppet itself, but some of it is Puppet plus the PowerShell DSC. I think there was a vBrownbag covering that as well. But it uses a combination of it, so you can write things. Let me go back to the profile. So this thing here that says package R10K provider gem, if I was running Linux, it would use the Ruby gem to install that. If I'm using Windows, clearly it's got a dependency on Ruby being there because that's not part of Windows. But if you had that there, you could certainly install it that way.
So there's actually a like a Microsoft-specific section of Puppet Forge.
Yes.
And just doing some quick Googling in the background, it's Azure has all manner of Puppet integrations, and then PuppetLabs.com /Microsoft describes everything and everything and anything that they've got going on, up to and including the Puppet Labs and Visual Studio integrations. So.
All right, and then what R10K does? So it goes out and the hero one, we don't have any branches, so it grabs the main branch and deploys it in that location. For the control repo, it finds that there's a branch called production, so it creates this production directory underneath the etc Puppet environments directory. And then for all the Forge modules, it uses Puppet module install, just like we had done earlier for the ZAC R10K module, to go out and grab the latest version. And then down here, these last 5 from the highlighted section down, that actually goes and uses Git. So like I said, as long as this guy has connectivity to GitHub or your stash server at work or whatever it is, it can go out there and connect to it. Now, it's also smart enough, if I run this again, you saw it took a little bit of time the first time. It's not instantaneous, but you can see it sees everything is up to date, so it doesn't do anything. So when you go and you make a change to, say, your profile or just your hero data, that's the only thing that it will update. And in fact, we can see what it put out there by taking a look. And those are all the files that we would expect coming from the Forge, or from the repository. And if we take a look out here, we've got all the modules. And if we take a look in the manifest directory and we cat that file, we've got the same file that we saw earlier when we poked at the control repo. All right, so the next step, go back to half screen here, is that we need to actually use Puppet to build the Puppet service. But to do that, our template only had the Puppet client, not the Puppet server. So we're going to take a quick second to install that. And that only takes a second to get started. Now, normally, once you're at this stage, you can use this Puppet agent -t with the no-op flag. A no-op flag means that nothing is actually done. However, when you do that, it's going to show a lot of red, and it's going to try and fake what's happening, but at some point you get to a resource that depends on an earlier resource that was faked, so some underlying dependency isn't there, and then the whole screen becomes red and green, and it's very seasonal this time of year, but it's not very helpful. So we'll skip that step, and we'll just run Puppet agent-t, and this is the best part of the control of the live demo, because I've got my fingers crossed the whole time, and hopefully this part works great. What it's doing now is it's copying down some providers, facts, and types, which are all code that's used by the agents. Now, this is the Puppet master, but it's also its own agent. So it's copying those files from the master process down to the agent process. So even though it's local, it still does the copy. On all the nodes, you'll see this on the first check-in. And then once it's done with that, it builds this catalog for this node, and it's going to start installing all the stuff. A few other things while this is running, because it's going to take a while. If you are taking snapshots as you work on this, you want to take a snapshot right after you do your service Puppet master start, because it's going to generate an SSL cert. If you then have a node that checks in and gets that cert, if you were to roll back prior to that point, it would generate a new cert, and then when your node checks in, it's not going to identify the master, and there's a pretty lengthy process to clean out certs, and it's really a pain. So if you're going to take a snapshot, make sure you've got that generated cert. And the other thing is the resource allocation. You can find some guides out there. There's like some upper thresholds for the number of nodes you can manage, but I think for most people, 2 core, 4 gig of RAM, you should be able to manage, start approaching the 1,000 node limit. So I've got obviously less than that here in my lab. I think I did 2 core and 2 gig, but you know, if you feel the need to, just bump the resources up. Sometimes Puppet will take a while to run because it's doing a bunch of things in the background, and you might have to run it twice if you're in a constrained lab. But the great part is it's idempotent, which means running something twice won't have negative effects. It always tries to converge to the desired state that you suggest. And this part is going to take a bit. So Cody, do we have any other questions?
Not showing.
Okay.
You know, it always happens. I look away for 10 seconds or so, and somebody's typed one in. So maybe.
All right, and like I said, this is the part I'm really crossing my fingers on. Hopefully everything goes well with this Bootstrap, and we'll be good to go. I will note that the most intensive process is that puppetdb. It's got to create and start and populate the database, and sometimes that's the part that you just need to run Puppet agent-t twice for. It can just hit the timeout thresholds, and then you run Puppet again, and it'll do like one thing after that, if you're lucky. And I've also seen some issues, which might be running into, where the firewall processes sometimes seem to freeze up the SSH connection. It almost always resumes. But because this is a live demo, there's a great possibility that we might run into that issue tonight.
SSH is wonderful in that regard. I've shut a laptop with an open SSH connection, driven an hour and a half home, opened it back up, and it, I don't know, about 40% of the time will resume the connection for me. Sometimes it's not been, but it is fairly robust in that regard.
Yep. Some other things, you saw up here we did a service Puppet master start. Puppet open source out of the box comes with a WebBrick web server that handles one connection at a time. If you've got 2 nodes on the network and they're alternating runs, you're great. And then you add a few more nodes, and eventually 2 nodes try and connect at the same time, and either one of them loses or both of them loses if the WebBrick server can't handle it. So part of this setup is to use Apache and Passenger. That gives you the scalability so you can handle up to 1,000 nodes or so. And as I mentioned before, Hira, PuppetDB are also installed at the same time. All right, there we go. We got caught up. Nope, and I saw a little bit of red there. So we'll wait for this to finish, and we'll see what happened. Looks like it might be the Postgres step.
Yep.
All right, so we get to see a lot of red anyway. I am scrolling back, and hopefully, yes, it looks like it is Postgres that caused our failures. Let me make sure that domain works. This is where I've run into issues where, yeah, it says it can't talk to the device and it's got to find a mirror. Okay, so that was our problem. The problem wasn't Postgres, the problem was actually talking to a mirror. So now, when we run Puppet Agent again, and I have had some connectivity issues today, which is always awesome when you're doing a live demo. We have to restart the Puppet service again because it actually stops it because it's trying to switch over to Apache, but Apache's not there. These are things that hopefully shouldn't happen if you run this yourself, because hopefully your connection is better than mine apparently is right now. Keep our fingers crossed again. There we go, it installed it this time. So as you can see, it's not doing all the firewall rules that it started out with last time because those are already there. So that's kind of what that idempotent stuff means. It means it's going to converge on the state and it's not going to do the same things over. If anybody here has tried to do bash scripts or something else to do these kinds of setups, we all know how easy it is to forget some check and have it try and wipe out something that's already working. So I prefer this to trying to handcraft it myself. All right, to save a little bit of time, I'm going to jump ahead to the DNS server. So the second node that you would create in your PuppetInABox environment is DNS, because without that, you ain't going to get very far. So we saw the DNS data that I modified. As long as you've got good data in the repo, as long as it's syntactically valid, standing up the DNS node is really, really easy. You spin up your new VM, you call it DNS, and you give it the prescribed address. Obviously, I've used a slightly different one. We are at 10.0.1.253 instead of 10.0.0.253. And we've got that alive in the back. Yeah, spin it up. We need a host entry because when an agent checks in, by default, it's going to look for a node called Puppet. If we do ping Puppet, we get nothing. So back in that control repo, and I've got to look at my copy of it, we have this host add.pp. So just copy this file. Paste the contents in. The indentation doesn't really matter. And we're going to use Puppet apply, which unlike agent that checks into a master, this actually runs the commands that are present in the file that you give it. You can also use Puppet apply -e to run a script inline. And I can show you that in a minute. So we add that, it adds the Puppet host, and we can ping Puppet. And all that really did for us was add this line to etc host. You can certainly do that by hand. I just tried to make this easy for anybody who's doing this. It's very repeatable. All right. So back on the master, we saw that we did have this issue. You can see here it's trying to connect to Postgres as it's starting, and it timed out. So we just run the Puppet agent one more time. Oh, and you can see here that it restarted it started the service HTTPD. As I mentioned, we go from the Puppet master service to HTTPD. So this time when I run Puppet agent -t, everything works fine. And you can see it does just a little bit more to converge the data. Here we have the SSH key that was exported on the last run now being imported. So the Puppet master is all ready. It took a little longer than I wanted. I'm going to blame that on it being a live demo, but you've got Apache, Hira, PuppetDB, the R10K software is installed. You're ready to go. All right, so now back on the DNS server, all we had to do here was add that host, and now we can ping Puppet, so we can run Puppet agent -t. And on the first time you run Puppet, just like on the master, it generates a certificate file and it sends it over to the master. So if we go back over here, we can do a Puppet cert list, and we see this cert that needs signed. So we do a Puppet cert sign, put in the DNS name, and it is now ready to connect. So if we run Puppet agent -t again, and I will make this full-sized so we can, full-size so everybody can see what's happening without the line wrapping. It's going to check in, and it's going to get everything that we define in the class, in the role DNS class. You can configure auto-signing. I just don't like the idea of a default to allow devices to connect. If you want to, there's plenty of instructions on Puppet Lab's site to help with setting up auto-signing. You can do it by network, you can do it with VCO, however it might work for you. And this is going to go a little bit faster than the other one, but we still have a minute or two. Any other questions?
Not as yet, other than reiterating how critical DNS is to
Yes.
this entire endeavor.
DNS is very critical. Always critical.
Actually, I do have a question. It's more personal curiosity than anything. Do you do any sort of caching within this environment? So it's going out and doing a lot of fetching, a lot of installing, a lot of pulling in Postgres, and so on. And these are not tiny packages by any means. So if I were to be using this on a spot with less than optimal internet, say I had one of the big 3 providers, but was experiencing whatever caps and so on. I'm on a rural telco out here, so I do get my days where like bandwidth is, like I'm lucky to have an IP address and a ping with a latency of several thousand milliseconds. So do you do any caching within the PuppetInABox?
No, PuppetInABox doesn't do any caching because for the most part it's relying on the underlying OS. The only part where you actually could control the caching, I mean, you can certainly use like a proxy if you want. I don't have that set up, but you could certainly set up for it. But the forge here, you could mirror the forge if you wanted to, and there's things that will help you do that. It's basically like rsync that runs at midnight or something, some sort of off hour. So you can actually point to a local forge mirror. And all those Git things are pointing to GitHub, but you could have those running on a Git server in your home lab, so you don't have to leave the network. Now, things like Postgres, that's going to the EPEL repository. There are ways to mirror that too, and you basically set up a local mirror or use some sort of proxy that connects to a local mirror, or maybe even do something to intercept packets and rewrite destinations. But that's not PuppetInABox.
I've actually got a Squid server that runs on my Raspberry Pi with an external USB disk.
Yeah. Yeah, you
it
could do
works.
something like that.
It's not the best, but it works.
Yeah, and you could use Squid to do some rewrites if you wanted to just simply point all the URLs to a local repository instead of having to muck with proxies and changing the repository definitions and all that good stuff. So one thing I want to mention here, I talked about the known host. You can see here I'm on the DNS server, and I got the known host from Puppet. So if I SSH to Puppet, you'll notice it just gives me a password prompt. On the Puppet device, since I haven't run Puppet again, if I SSH to DNS, okay, remember I talked about how I cheated with the resolve.conf? You gotta flip that back when you're done. Okay, so now if I SSH to DNS, I get asked for the authenticity. That's simply because I haven't run Puppets on the master since the DNS node checked in and exported that certificate. If I run it again, I should get that key, and then it won't ask me that anymore. That's what I was talking about earlier when I talked about the SSH identity keys. And hopefully that won't take too long, but I'm going to go show you. And there is one other thing that we need to, well, two other things. One, we need to get rid of our host entry. I'll show you that in a second. But the other thing we need to do is actually start Puppet. So we got the master running here. Oh, now we can do that. It doesn't ask us for the identity. So we want to start, make sure Puppet is going to start on a reboot, and then we actually start the Puppet agent. Now that's the agent, not the master. Every 30 minutes by default, this device is now going to check in with the master. So we definitely want to do that on the DNS server as well. And I mentioned the need to get rid of this because now we have it in DNS, so I get rid of that. As I mentioned, you can use that host remove file, you can take it out, you can use puppet apply -e, whatever you want. Now if I ping Puppet, it still works. And if I ping my build or my yum repo, I actually get a resolution, but of course they're not on the network, so they don't respond. But we know DNS is working, and we can try that over here as well. So you've got right now 2 nodes, but it's the basics of setting up your network. The next one would be DHCP, and then you could add your build or yum repo servers, and then you can add whatever else you want, different modules and roles and profiles, and keep growing your network from there. So whether you know Puppet well or you're just cutting and pasting commands from that web page, you should be able to stand this up pretty quickly. So I mentioned that there's those built-in roles, and you can add to those. Say you want to manage some web servers. I'm sure everybody wants to do that. All you do is you go out to the profile, add a new profile here, call it www, and start adding in different things. I've got an Apache profile out here that you can use as the basis of it. It installs Apache using the Puppet Labs Apache module, and it creates a rule for port 80 inbound. So you've got the basis of it, and all you do is then go out to the role and start layering things together. I've got this web server one, which doesn't do a whole lot. It just sets up Apache, doesn't put any files there. But at least if you created a node called web server and made sure that in here, we don't have one. But if you made something called web server here and added that role : web server, or yeah, role web server, it would get those profiles and it's good to go. If you need multiple devices of the same type, like DNS, just call it DNS1, DNS2. You can put numbers at the end of the host name, and Puppet doesn't care about that. So you could do, you know, a web farm would be web server 01 through web server 99. Whatever you need to do, it's smart enough to take those off the end and go out there. So when you create your new one, just match that up. And don't forget that after you make changes to these, to your repository, you've got to commit it locally. You got to push it to GitHub or whatever you're using, and then rerun R10K. Same thing if you're doing any branches. I mentioned that if you want to test your changes, which you absolutely want to do, you just need to build a new branch. So I've got the control repo here. We're going to use git checkout -b feature. We'll call it feature 2. And we do a git push origin feature 2. So that pushes it up to GitHub. And if we now run our 10K, and we're going to do it in verbose mode, you normally wouldn't do that, you should see it has found that branch, and it is now deploying another environment. You could, on the other agent, simply add the environment option, and it would check in to the Puppet Master and tell the Puppet Master that it wants to use the feature 2 environment. So anytime you make the changes, you just push them out, run our 10K, and they're there. Now, that's the little high-level overview. There's certainly a lot of small intricacies to it. When you branch that, you need to make sure that the Puppet file in the control repo points to the right reference in your GitHub, and there's other tools like Reactor, R-E-A-K-T-O-R, that you can use to automate some of that for you. And I mentioned those slides before for our 10K with the workflow. Take a look at those. Those will go through all the details that you need. Yeah, and this is a little slow, but we'll show this in just a second. So if you needed to update the zone file, all you need to do is go make a change in that in the lab config module to the zone file, commit it, push it, rerun our 10K, and when your managed nodes check in, say every 30 minutes, if you don't run it manually, those changes are made live within that 30-minute time frame. And over here you can see it checks in with environment 2. We have made absolutely no changes, so there should be nothing for it to do. If I run it with feature 3, which doesn't exist, we can see we get an error. So we know that we get a whole bunch of errors. So we know we're actually running on a branch that exists. So that is Puppet in a box and some of the workflow surrounding it. Do we have any questions?
Sorry, talking into my mute button. Do that at least once an episode, so I've met my quota. No questions as yet, I don't think.
Okay. Let me go back to the PowerPoint. All right, so as I mentioned, roles, profiles, pattern, Craig Dunn's website, R10K. There's an official workflow guide. I've got a new module, an existing workflow guide, blog post. Those go into a little more detail, but they're basically mirrors of this. And just like to give a little thanks, obviously, Puppet Labs for creating Puppet. Adrian Thiebaud is the creator of R10K. Noel Finch on Twitter, great guy to follow. Matt Brender for the 12 days of commitments for getting me to follow through on using Git and spawning this project, so I blame him. And of course, vBrownbag, Cody Bunch and company for inviting me back for another presentation. And of course, everybody for listening. Thanks for listening, and I hope you guys enjoyed it.
No worries. Thank you so much for presenting.
Sure.